good to know. All right. Let's pick up where we left off before. Now, this is a pretty tough problem. Take a look at it, read it. Maybe you have the kind of mind that can get this based on the sentences. Most people don't. Any ideas?
I'm just
All right, let me make some suggestions. First of all, this is difficult, not because it's difficult, it isn't, but there's multiplication and division required, okay? Whenever you have multiplication and division required, it kind of scrambles the brain, and it's difficult to figure out what to do. However, this is a classic pick numbers problem. Okay? By picking numbers, what the sign is as to when you want to pick numbers is we have a variable in the paragraph, m, and we have that same variable in all of the answers. Sometimes you'll have a question that'll have 3 variables in the paragraph, and all of the answers have all 3 variables. So whenever you see the same number of variables in the paragraph as are in the answer, you know that you could substitute any m you want, and it has to be true, right? In other words, they're not telling you what m is. They're just giving it to you as a variable. So, if I'm going to pick a number for m, what would be the smartest number I could pick? I can pick anything I want.
Would be 1.
Okay, so I'm going to walk 4 miles in 4 minutes. All right, that works. I'm going to walk 4 miles in 4 minutes, right, if m is 1. How many miles would I walk in 15 minutes?
15.
Okay, so I have to find an answer out of these 5 answers that's equal to 15 when m is 1. Well, which answer is that? Plug in m equals 1 until you get 15 as an answer.
It would be D.
Yeah. So even though we didn't know how to set this up, we knew how to solve it. And there was actually all kinds of m's I could have picked. The m I would have probably picked was 12. Why? Because then it says if you can walk 4 miles in 15 minutes, how many miles can she walk in 15 minutes? We know the answer is 4, right? So when m equals 12, the answer has to be 4. Well, if we go through all of these same answers, notice that when m is 12, that's 4. And that's the only thing that is 4 when m is 12. Everything else is different than 4. So when I say pick numbers, what I mean is pick a number that allows you to instantly figure out what the answer should be. Now, there was nothing wrong with 1 because obviously if you can walk 4 miles in 4 minutes, you're going to walk 15 miles in 15 minutes. So 1 was a very good answer. But 12 would also have been a great number to pick. So you kind of get the idea on how picking numbers and then back solving works?
Yeah.
Okay. And that can be used in a lot of places. And sometimes that is by far the easiest way to do it. Now, remember what the goal here is. The goal is not to impress upon any math teacher your knowledge of math. The goal is to get the answer. That's it. 100%. And it doesn't matter what method you use, as long as you're sure you're getting the answer. In other words, you do not have to set this up algebraically using the distance equals rate time formula.
Okay.
Okay? Okay, when you get a question like this that says, which of the following will yield an even integer, we basically are going to have to go through all 5 answers, right? I mean, there's no other way to do it. So, does F always yield an even integer, as long as n is an integer? So what you want to try are some odd and even n's.
Yeah.
It does, doesn't it? Okay.
Yeah.
And the thing to know is that even times even is always even. Even times odd is always even. The only thing that's ever odd is odd times odd, which is odd, okay? So, you know that if n is even, n squared is even, even number times even, that's going to be even. But if n is odd, n squared is going to be odd. But an even number times an odd number is still even. So regardless of whether n is even or odd, you got those two situations where the result is always even. Notice if we look at some others, well, that's sometimes even, sometimes odd, but when you add 1 to it, it becomes the other. Same thing with this. Sometimes even, sometimes odd, but when I subtract 1, it becomes the other. Well, 3 times an odd is odd, but 3 times an even is even. And this is, well, that's sometimes odd, sometimes even. That's always even. So you have odd minus even, which is odd. This is only even if n is even. So the only one that is always even is this one right here. And you don't really, if you're taking the test, because this is a time test, and time is critical, you don't, once you decide that F is the answer, in other words, no matter whether n is even or odd, 4n squared is even, you're done. Circle that as the right answer and don't spend your time on these 4 answers here, because you've already decided that 4n squared is even no matter what n is.
Okay.
geometry problems, if you can easily draw a picture, do so. Sometimes, if they're talking about a 20-sided polygon, do not take the time to draw a 20-sided polygon. It'll take you too long. But with triangles, this isn't a bad way to go. What is angle C?
90.
Okay. And we know that's A and that's B. So I've drawn the picture correct, right?
Uh-huh.
AC is 12. What's the perimeter of this triangle? Which means we have to figure out what CB is, and we have to figure out what AB is.
CB is 12.
Okay. What's AB?
Isn't it 12 root 2?
Very good. Very good. Based on my unit triangle. In other words, the reason I have been giving you this for a year is because you're going to need it. There's the unit. 45, 45, 90 triangle. Well, this is a similar triangle to this. What's the similarity ratio? 12 divided by 1. So every side of this triangle has to be 12 times bigger than every side of this triangle, which puts the hypotenuse at 12 root 2.
Okay.
Now, how come that answer isn't on there?
Wouldn't it be 24 plus 12 root 2? D.
Ah, it's the perimeter they want. So we have to add up everything. Yeah, it's 24 plus 12 root 2. Yeah, well, that shows you an excellent principle. Always know what it is you're looking for. I was solving for the hypotenuse, and they were asking for the perimeter. So they were nice enough not to put 12 root 2 as an answer. Otherwise, I would have gotten it wrong. But the fact that that was not an answer put up a giant red flag for me, telling me I've made some kind of mistake. Let me go back and reread the problem. You get what I'm saying?
Yeah.
Okay, let's go to the next. And they usually will do that, especially with a hard problem. If they won't put the trap answer on there, they just won't do it. They'll give you a chance to review your work by here, I need to lower this a little bit. You know what I'm saying? I mean, if they really wanted to be mean, they would have put 12 root 2 as an answer. And then I would have gotten it wrong. You might have gotten it right, but I would have gotten it wrong. All right, this table applies to questions 44 and 45. So, read 44, and based on this question really is more of a science question. Have you taken a practice ACT, Mitch?
No.
All right, well, there's two verbal sections. There's a math section, and then there's what they call a science section. And the science section does not require you to know anything about science at all. But what it does require you to do is be able to interpret tables and charts and graphs. And then what they do is they give you the tables, charts, and graphs, and they ask you questions about them. So this question here, to me, really belongs in the science section. But I don't generally review the science with students because it's not really science, it's verbal. It's how well you can read. Well, let's see if we can do this one. These are generally pretty easy. You just have to figure out, make sure you read the details properly.
2002.
Good. And they're looking for absolute value here. They're not looking for percentage increase. In other words, the difference 2002 is almost 200. No other year to year increased by 200. Not even close. And like I said, they didn't say the greatest percentage increase. Otherwise, you would have to take every year and divide it by the previous year to figure out the percentage increase. Let's see if you can still read that. Not quite. All right, you can still read the table. Can you read the question?
Yeah.
And I need to bring the title down. Notice what the title says. This is the town of Potterville only, situated in Eaton County. So the very first thing that's surprising about question 45 is the fact that it talks about Eaton County, not Potterville. Notice that the figure for 2000 in my table is 176, and they're telling me 652. So automatically that should alert you to the fact that Eaton County is not what's being shown in this table. This table is Potterville. So what ratio is going to give us the answer to 45?
B.
Well, 176 divided by 652, correct?
Yeah.
And that's B. All right, I'll take your word for it that that's
It's
B.
26.9 or
Okay.
20.9%.
Okay. This would be very hard to understand if this is all the information you were looking at. Well, no, hold on. Excuse me. If that was all the information you were looking at. Because it's necessary to read the title of that table to know that this is Potterville and they're talking Eaton County, a bigger area. You see what I'm saying?
Yeah.
Okay. Let's go to 46. Let's blow it up a little bit so you can see it a little better. Another tough question. When you have two equations and two unknowns, when do you get an infinite number of solutions?
When both sides equal 0.
Well,
Equal the same thing.
how many solutions do you get to just equation number 1?
2.
No, you get
Or no.
You get infinite. In other words, when I have two variables and one equation, there are literally an infinite number of solutions. Remember, x and y can be non-integers.
Oh, yeah.
They can be positive or negative. So when you have two variables and one equation, it's always an infinite number. Well, what if I did this? Gave you a second equation like this. Have I added any information? Have I given you any additional information? No, I have not. Because all I did was multiply the first equation by 2. So how many solutions are there to these two equations? Still infinite. Still infinite. In other words, this situation here is the same as just having one equation. That second equation is not a different equation. It is the same equation multiplied by 2. So if I have an infinite number of solutions here, I've got an infinite number of solutions when I have both of them. Well, notice what they're asking here. The second equation looks very close to the first equation, does it not?
Yeah. Except, yeah. Except the,
what would this number have to be so that it's the same equation?
90.
60.
Wait, what? Yeah, 60.
3 times 20.
Yeah.
Because this number is 3 times that, this number is 3 times that. If that were 60, then I would have an infinite number of solutions to this system of equations. So what does A need to be?
2.
You got it. And they do like to ask questions about 2 equations and 2 unknowns, similar to this. They're always part of the hardest questions. In other words, this is definitely a difficult question, but they are very fond of doing that. Let's do one more and call it a session. Good, it's a log problem.
Yay.
Well, come on, you know logs by now, don't you?
Yeah.
So if I say the log base x of 169 equals 2, give me what the exponential expression would be. That's the total answer. If you can convert this to an exponential expression, you'll be able to solve it very easily. It's the number on the far left raised to the power on the far right equals the argument. So x squared equals 169. What is x?
13.
Yeah. So the only thing you need to know for their log questions are how to convert logarithmic to exponential and back and forth. If I have y equal b to the x and I want to express that logarithmically, well, the one thing I know for sure is that logs are exponents. So I can write that for certain. Well, where does the b go? The b always goes down there. The only other place is the y right there. So if I'm going from exponential to logarithmic, I do it this way. But if I'm going the other way around, it's the number on the far left, b, raised to the number on the far right, x, and it's equal to the argument. So know how to convert between logarithmic and exponential. If you know nothing else about logs, you need to know that.
All right.
All right, Mitch, I will talk to you next week.
All right.